Welcome students, this is the class on trigonometry. We will be looking into the trigonometric identities, and this is the identity study guide. So let's start. First question, you are supposed to reduce, and the question given is cos x positive tan x times sin x. So this is the expression given, and you will have to reduce this and you will get a result. So this expression which is given results in the value that we would be producing. So thereby we would establish an identity. So having said that, let me give you this hint. Always whenever you see cot x and tan x, you convert it into sin x and cos x. That's the all important point you have to know. So this is cos x positive, tan x is sin x over cos x, and you have sin x here. This is nothing but cos x positive, sin x times sin x is sin squared x divided by cos x. I take the LCM as cos x, so that would give me cos squared x positive sin squared x. Cos squared x positive sin squared x is 1, so this is nothing but 1 over cos x. Now by trigonometric identity, 1 over sin x will give you cosecant x, and 1 over cos x will give you secant x. So this is just a side note. So 1 over cos x, that's going to give you secant x. So we have obtained the reduction. So thereby, in the process of obtaining the value, we have got an identity. What is identity? Cos x positive tan x times sin x is equal to secant x. So you can actually box the result. So let's go on to the next one. So this is question number 2. We have to reduce cosecant x negative sin x divided by cos x. Now we can start off by stating consider this. Now what I would do is I will replace cosecant x by 1 over sin x. So that is there, followed by sin x divided by cos x. Now take the LCM as sin x, that would give me 1 negative. This is actually resting over 1. So that would mean sin x into sin x is giving us sin squared x divided by cos x. Now remember this all important identity. Sin squared x plus cos squared x is equal to 1, which means 1 negative cos squared x is equal to sin squared x. Also 1 negative sin squared x is equal to cos squared x. So we would have to use this all of the time. So 1 negative sin squared x is cos squared x divided by, now this is actually resting over 1. So if you were to flip it, you are going to be getting sin x times cos x. Cos x and cos x can be cancelled, giving you cos x over sin x. So cos x over sin x is nothing but cot x. So remember, a point to remember, cos x over sin x is equal to cot x, and sin x over cos x is equal to tan x. All important formula. So that is question number 2. We will move on. So this is question number 3, tan x over secant x negative cos x. So as usual, I will start off with that word consider, and if you would bear to remember, I mentioned that whenever you have tan x and cot x, convert them into sin and cos. So I will rewrite tan x as sin x over cos x divided by secant x has got a formula as 1 over cos x followed by negative cos x. This is equal to sin x over cos x divided by the LCM as cos x. This is resting over 1. So if I were to take the LCM as cos x, this is going to give me 1 negative cos squared x. So this is equal to sin x over cos x divided by 1 negative cos squared x is sin squared x divided by cos x. if you were to flip that, this is going to be sin x over cos x times cos x over sin squared x. Cos x gets cancelled, sin x and the sin gets cancelled, giving you 1 over sin x. Now 1 over sin x is nothing but cosecant x. So therefore you have an identity. What is that? Tan x over secant x negative cos x is equal to cosecant x. So that's a beautiful result. So that is the solution. We'll move on to the next one. So we got this next one, 1 positive 2 times sin x divided by 2 positive cosecant x. So what I would be doing is I would start off with that all important word, consider. So this is rewritten as 1 positive 2 times sin x divided by, now cosecant x is going to be rewritten as 1 over sin x. So this is equal to 1 positive 2 times sin x divided by, I take the LCM as sin x, so this would give me 2 times sin x positive 1. If I were to flip it, this is going to be 1 positive 2 sin x times sin x divided by 2 sin x positive 1. I'm going to write it as 1 positive 2 sin x. So I will write the first term as 1, the term over here as the second term. Now 1 positive 2 sin x and 1 positive 2 sin x gets cancelled, giving me sin x. So therefore you have another important identity, which is 1 positive 2 times sin x divided by 2 positive cosecant x is equal to sin x. Right, so that is an important question. We'll move on to the next one. We got question number 5. We been given 1 over 1 negative cos x positive 1 over 1 positive cos x. So let me start off by stating consider. I'll take the LCM as 1 negative cos x and 1 positive cos x. So this would give me 1 positive cos x, because 1 negative cos x, 1 negative cos x gets cancelled, followed by positive, and over here I will get 1 negative cos x. So this is going to be 1 positive cos x positive 1 negative cos x divided by, now a positive b multiplied with a negative b would give me a squared negative b squared. So this is going to be 1 negative cos squared x. Now positive cos x negative cos x gets cancelled, 1 added with 1 will give me 2. 1 negative cos squared x is going to be sin squared x. Now I can rewrite this as 2 times of 1 over sin squared x. Now 1 over sin squared x can also be written as 1 over sin x raised to the power of 2. Now 1 over sin x is nothing but cosecant x. So this is cosecant x raised to the power of 2, which is nothing but 2 times cosecant squared x. So you have an important result. What is that? So this means 1 over 1 negative cos x plus 1 over 1 positive cos x is equal to 2 times cosecant squared x. Right, so that's a nice result. Let's move on to the next question. So the next question is 2 positive tan squared x over secant squared x negative 1. As I've already mentioned to you, whenever you see tan x and the cot x, convert them into sine and cos. So first what I will do is I'll start off by stating consider. So this is equal to 2 positive tan x is sin x over cos x, but since we have got the exponent value to be 2, I'm going to get sin squared x over cos squared x divided by secant squared x is 1 over cos squared x followed by negative 1. So this can be rewritten. We can take cos squared x as the LCM, and that would give us 2 times cos squared x plus sin squared x followed by a negative 1 and divided by 1 over cos squared x. This can be further rewritten as 2 times cos squared x positive sin squared x divided by, now you have cos squared x in the denominator. Now this term is actually like this, right? So if you flip it, cos squared x would be occurring here followed by a negative sign. away from the denominator. So this is equal to 2 times cos squared x plus sine squared x. Since cos squared x gets cancelled, followed by a negative 1. Now what I wish to do, I would like to write 2 times cos squared x as cos squared x plus cos squared x plus sine squared x negative 1. Now I mentioned to you that sine squared x plus cos squared x is equal to 1. So this is going to give me cos squared x plus 1 followed by negative 1. Plus 1, negative 1 gets cancelled, giving me cos squared x. So therefore we have an identity. What is that? 2 plus tan squared x over secant squared x negative 1 is equal to cos squared x. So this is problem number 6. We will move on to problem number 7. So this is the next question. We are expected to evaluate tan of x negative pi over 4. Now for this I am going to be utilizing this formula, tan of a negative b, which is equal to tan a negative tan b divided by 1 positive tan a tan b. So this would mean tan of x negative pi over 4. In place of a you substitute x, in place of b you substitute pi over 4. So that is going to be tan x negative tan pi over 4 over, in this case it would be tan x times tan pi over 4. Now we know that tan pi over 4 is nothing but tan 45 degrees, which is nothing but 1. So that would mean we got tan x negative 1 divided by 1 positive tan x, right? Now you can rewrite this as tan x negative 1 divided by tan x plus 1. And what is that? That's nothing but tan of x negative pi over 4. So this is an all important result. Now you might be wondering, okay, you have given the equal identity for tan of x negative pi over 4. What is the situation for tan of x positive pi over 4? Okay, let's also do that. Now tan of a positive b is equal to tan a plus tan b divided by 1 negative tan a tan b. So I take a is equal to x and b is equal to pi over 4. This would mean tan of x positive pi over 4 is equal to tan x plus tan pi over 4 divided by 1 negative tan x times tan pi over 4, which is equal to tan x plus 1 divided by 1 negative tan x. I can rewrite this as 1 positive tan x over 1 negative tan x. So this means tan of x positive pi over 4 has a beautiful result, which is 1 positive tan x over 1 negative tan x. Okay, so I'm going to take this as problem 8, and now I'll move on to do problem 9. Now this is a very important result, that is the identity for cos of 3x. Now what I wish to do, I will start off by stating consider, then I will rewrite this as cos of x positive 2x. Now we know that cos of a plus b is cos a cos b negative sine a sine b. So by this formula, this is equal to cos x cos 2x negative sine x times sine 2x. Okay, now cos 2x is there. There is a formula which is written as follows: 1 positive cos 2x over 2 is equal to cos squared x. So from here I can rewrite this as cos 2x is equal to 2 times cos squared x. Rewriting this further would give me cos 2x is equal to 2 times cos squared x negative 1. So in place of this, substitute this. So this is equal to cos x times 2 times cos squared x negative 1 negative sine x. Now sine 2x is equal to 2 times sine x times cos x. This is also a very important formula. So this is going to be 2 times sine x times cos x. So distribute cos x, so that's going to be 2 times cos cubed x negative cos x negative 2 times sine squared x times cos x. Now we know that sine squared x is equal to 1 negative cos squared x. Substitute that over there, so it's going to be 2 times cos cubed x negative cos x negative 2 times 1 negative cos squared x times cos x. So this is equal to 2 times cos cubed x negative cos x negative 2 times cos x negative positive 2 times cos cubed x. Now 2 times cos cubed x and 2 times cos cubed x can be added, giving me 4 times cos cubed x. Negative cos x and negative 2 times cos x can be added, giving me negative 3 times cos x. So therefore what do we have? Cos 3x is equal to 4 times cos cubed x negative 3 times cos x. So this is the all important result we have. So that is the end of problem number 9. Now we got question number 4, cos 4x. Now what I wish to do, as usual, I'll start off with the word consider. Then I'll rewrite cos 4x as cos of 2 times of 2x. Now this is similar to cos 2 theta. I have given you the formula that cos 2x is 2 times cos squared x negative 1. So cos 2 theta is 2 times cos squared theta negative 1. So in place of theta I have 2x. So that would mean therefore cos of 2 times of 2x is equal to 2 times of cos squared 2x negative 1. So in place of cos 2 of 2x I will be substituting the quantity on the right side. So this is equal to cos 2 times of cos squared 2x negative 1. Okay, so that is what we've got. Now what I'm going to do is I would have to break this as 2 times of cos 2x raised to the power of 2 negative 1. Now again apply the same formula. So that is going to be equal to 2 times of cos 2 theta is 2 times cos squared x negative 1. Now this has to be raised to the power of 2 followed by negative 1. So there is quite a lot of steps involved. So you got to be careful. So you use a negative b whole squared formula, which is nothing but a squared negative 2ab plus b squared. That is going to give me 2 times cos squared x raised to the power of 2 minus 2 times of cos squared x negative positive 1 raised to the power of 2 negative 1. So this is going to be 2 times of 2 raised to the power of 2 4 cos raised to the power of 4 x negative 4 times cos squared x positive 1 negative 1. So distribute 2, so that's going to be 8 times cos raised to the power of 4x negative 8 times cos squared x positive 2 negative 1. So this can be rewritten as 8 times cos raised to the power of 4x negative 8 times cos squared x negative 2 positive 2 negative 1, that's going to be positive 1. So this is what you have got. Now we got the 11th question, cosecant of cos inverse of x. Now what I wish to do is I would like to take theta to be equal to cos inverse of x. So if I were to move cos inverse to the left, I would get cos theta is equal to x, which is nothing but x over 1. Now draw the right triangle. So you got A, B, C. This is opposite side, this is adjacent side, this is hypotenuse side. Now cos theta is adjacent side divided by hypotenuse side. Now the adjacent side value is x, hypotenuse side is 1. So if you were to draw and place in the values, this is going to be x, this is going to be 1, this is a, this is b, this is c. I want to get the opposite side. Since it's a right triangle, ab squared plus bc squared is equal to ac squared. I know ac squared, I do not know bc squared, I know ab squared. So this is going to be 1 negative x squared. So therefore bc is equal to root of 1 negative x squared. Place that value 1 negative x squared. Okay, so if I were to rewrite this, if I were to take this as, okay, I will just state here, therefore cosecant of cos inverse of x becomes cosecant of cos inverse of x is taken as theta. So this is cosecant theta. But we know only cos theta. From cos theta we have completed the entire right triangle, and we also know that cosecant theta can be rewritten as 1 over sine theta. So from the triangle I can get sine theta is opposite side divided by hypotenuse side. Now my opposite side is square root of 1 negative x squared, hypotenuse side is 1, which is eventually going to give me square root of 1 negative x squared. So substitute that, that would give me 1 over 1 negative x squared, which is apparently the value of cosecant of cos inverse of x. So that is the solution for our question. Now we got question number 12. We are expected to evaluate cos of 2 times cot inverse of x. Now we know this formula, right? 1 positive cos 2 theta divided by 2 is equal to cos squared theta, which can be rewritten as 1 positive cos 2 theta is equal to 2 times cos squared theta, which is nothing but 1 positive cos 2 theta is equal to 2 times cos squared theta negative 1. So I'll be utilizing this result. In place of theta we got cot inverse of x, so this is equal to 2 times cos squared of cot inverse of x negative 1. Okay, now let me take theta to be, this is a side note, theta is taken to be as cot inverse of x, so that would mean cot theta is equal to x, which is nothing but x over 1. Okay, so also cot theta is nothing but 1 over tan theta, and that would mean I can also rewrite tan theta to be as 1 over cot theta, but cot theta is x over 1, so that would mean tan theta is 1 over x, which is nothing but opposite side divided by adjacent side. So if you were to draw the right triangle, opposite side is 1, the adjacent side is x, this is my theta, this is a, b and c. So this is the representation for tan theta. Now that would in turn mean, by applying Pythagoras, ab squared plus bc squared is equal to ac squared. ab squared is x squared, bc squared is 1 squared. so that is AC squared. So therefore AC is equal to root of 1 positive x squared. So this is going to be root of 1 positive x squared, right? So what I am going to do now is I'll use this page. So that would mean my value, so I need to get, okay, so I've got tan here, so let me just go up and get the value for this particular expression which we got. So therefore 2 times of cos squared of cot inverse of x negative 1 is equal to 2 times of cos squared of cot inverse of x is taken to be as theta. So you have theta there followed by negative 1. So this is equal to 2 times of cos square theta negative 1, which is equal to 2 times of cos theta raised to the power of 2 negative 1. So I need to get cos theta from here. So from figure, what is cos theta? Cos theta is adjacent side divided by hypotenuse side. So my adjacent side is x, hypotenuse side is root of 1 positive x squared. So therefore cos theta is x over root of 1 positive x squared. So that would mean 2 times 1 x over square root of 1 positive x squared raised to the power of 2 negative 1, which is equal to square it. You get 2 times x squared divided by square root of 1 positive x squared will give you 1 positive x squared negative 1. So you take the LCM as 1 positive x squared. This is going to give you 2 times x squared negative of 1 positive x squared, which is equal to 2 times of x squared negative 1 negative x squared divided by 1 positive x squared. 2 added with 2 x squared negative x squared will give me x squared negative 1 divided by 1 positive x squared. So this is what? This is nothing but 2 times of cos squared of cot inverse of x negative 1. But what is this exactly? This is what we have got, x squared negative 1 divided by 1 positive x squared, or else you can write it as x squared negative 1 divided by x squared positive 1. So this is nothing but my cos of 2 times of cot inverse of x. So this is the result, right? So the flow goes in this fashion. I hope you like this question. We'll move on to the next one. We got question number 13. We have to evaluate tan of 2 times cos inverse of x. Now I would like to draw your attention to tan of a plus b, which is tan a plus tan b divided by 1 negative tan a tan b. Now if a is equal to b is equal to theta, this is going to be tan of theta plus theta is equal to tan theta plus tan theta divided by 1 negative tan theta times tan theta, which is equal to 2 times tan theta divided by 1 negative tan squared theta. So therefore we have a result, tan 2 theta is equal to 2 times tan theta divided by 1 negative tan squared theta, which is a very important result. So using that result, if I take cos inverse of x to be equal to theta, then you have tan of 2 theta, which is nothing but 2 times tan theta divided by 1 negative tan squared theta. This is exactly what is this, right? So from here x is equal to cos theta. So that would mean cos theta is equal to x, which is equal to x over 1. Now let me flip the page and complete the question. So we have tan 2 theta theta is equal to 2 times tan theta divided by 1 negative tan squared theta, where theta is cos inverse of x, and that would mean cos theta is equal to x, which is equal to x over 1, and this is 90 ABC. Cos theta is adjacent side over hypotenuse, so this is x over 1. Applying Pythagoras, you get AB squared plus BC squared is equal to AC squared. I know AC squared, that's going to be 1 there. BC squared, I don't know. And AB squared is x squared. So BC is equal to root of 1 negative x squared. So this is going to be root of 1 negative x squared. So that is for cos theta. Now the question comes here is, we have to evaluate for tan theta, right? So that would mean tan theta is opposite side by adjacent side. Opposite side is root of 1 negative x squared, adjacent side is x. So take this and substitute here. So this is equal to 2 times of root of 1 negative x squared divided by x divided by 1 negative root of 1 negative x squared divided by x raised to the power of 2. So this is equal to 2 times the root of 1 negative x squared divided by x divided by 1 negative. You square it, you get 1 negative x squared divided by x squared. You take the LCM. So let me write the numerator. 2 times root of 1 negative x squared divided by x divided by x squared negative of 1 negative x squared divided by x squared. This is 2 times root of 1 negative x squared divided by x divided by x squared negative 1 positive x squared divided by x squared. This is 2 times root of 1 negative x squared divided by x divided by x squared is 2 times x squared negative 1 divided by x squared. So you flip it. This is 2 times root of 1 negative x squared divided by x times x squared divided by 2 times x squared negative 1. X and x gets cancelled, giving you 2 times x times root of 1 negative x squared divided by 2 times x squared negative 1. So this is my tan 2 theta. This is tan 2 theta. But what is theta? Cos inverse of x. Substitute that. So which is nothing but tan 2 times cos inverse of x. So this leads us to this. Okay, so this is the solution to this question. This is a beautiful question. We will move on to the next one. This is the next question, question number 14. We have been given secant squared x times cosecant squared x. So we are expected to write secant squared x times cosecant squared x as sum of terms. This is product of terms, but we have to change it into sum of the terms. So how are we going to do that? I'm going to rewrite the secant x to be as 1 over cos x and cosecant x to be as 1 over sin x. So this is going to be 1 over cos x raised to the power of 2 times 1 over sin x raised to the power of 2. This can be rewritten as 1 over cos squared x times 1 over sin squared x. I can further rewrite this as 1 over cos squared x times sin squared x. Now we know that cos squared x plus sin squared x is equal to 1. Substitute that in place of this one. So that is going to be cos squared x plus sin squared x divided by cos squared x times sin squared x. Now we also know that if you have a plus b over ab, I can write this as a over ab plus b over ab. So by this is rewritten as cos squared x over cos squared x times sin squared x plus sine squared x over cos squared x times sine squared x. Sine squared x gets cancelled, cos squared x gets cancelled, giving me 1 over sine squared x, positive 1 over cos squared x. We know that 1 over cos x is secant x and 1 over sine x is cosecant x, and you apply the exponent, you get cosecant squared x positive secant squared x, and this is sum of two quantities, right? And this is exactly what is required, right, as sum of terms. So I have written them as sum of terms, and that is an interesting question. We will move on to question number 15. This is the next question. We have to write cos x times cos 3x as sum of terms. Now for this I would be utilizing this all important formula. Cos A times cos B is equal to 1 over 2 times cos of A plus B plus cos of A minus B. Now this formula can be verified. First let me show you the verification that the right hand side is indeed equal to the left hand side. Cos of A plus B is cos A cos B negative sin A sin B, followed by cos of A minus B is cos A cos B positive sin A sin B. Positive sin A sin B, negative sin A sin B can be cancelled. Adding up cos A cos B, cos A cos B, you get 2 times cos A cos B. There is already 1 over 2. 2 gets cancelled, giving me cos A cos B. Okay, so this result is valid. Now taking A to be equal to x and B to be equal to 3x, this right hand side can be rewritten as 1 over 2 cos of x positive 3x positive cos of x negative 3x. This is equal to 1 over 2 times x added with 3x gives me 4x, cos of 4x, cos of x negative 3x gives me negative 2x, right? But since cos is even, that means cos of negative x is same as cos x, so that would give us 1 over 2 times cos 4x positive cos of 2x. So this is the sum of terms, right? In this case the sum of two terms. Now this can be further simplified, but since the requirement is just to write sum of two terms, I will just stop here and I'll move on to question number 16. We got an interesting question. This is question number 16. Express sine raised to the power of 4x as sum of terms with no exponents. So the final result shouldn't have any exponents involved. Now what I wish to do is I will start off with the word consider this. I'm going to rewrite this as sine squared x raised to the power of 2. Now we know that sine squared x is equal to 1 minus cos squared x, and also we know that 1 positive cos 2x divided by 2 is equal to cos squared x. So in place of cos squared x I can substitute this. That's exactly what I'm going to do. So this is going to be 1 positive cos 2x divided by 2, which can be rewritten as 1 negative 1 over 2 negative cos 2x. 1 added with negative 1 over 2 will give me 1 over 2 negative, of course there is a 2 there, followed by cos 2x over 2. I can rewrite this as 1 over 2 times 1 negative cos 2x. Now why did I do that? Because of the question's requirement. So I can take this and substitute it in place of sine squared x. That's exactly what I'm going to do. So this is equal to 1 over 2 times 1 negative cos 2x. This is raised to the power of 2. So this can be further rewritten as 1 over 4 times 1 negative cos 2x raised to the power of 2. Now you can expand this. This is going to be 1 positive cos squared 2x followed by negative 2 times cos 2x. Now we know that I will be utilizing the same formula, cos squared x. We know that cos squared x is 1 positive cos 2x divided by 2. Suppose x is equal to 2 times theta. So that would mean cos squared of 2 theta is equal to 1 positive cos 2 of 2 theta divided by 2, which is 1 positive cos 4 theta divided by 2. Right? You can utilize this. So this is equal to 1 over 4, 1 negative, this is without exponent, so you can write that out first, followed by cos squared 2x, cos squared 2 theta is this, so this is 1 positive cos 4 theta divided by 2. Right? Now you can bring this 1 over 4 inside. That would give me 1 over 4 negative 1 over 4 cos 2x positive 1 over 8 because of the presence of 1 over 2, and then positive 1 over 8 times cos. In fact, I don't have to write it as theta, I will place it as x because this is the side note, so I'm transferring it. Thereby the translation has to take place from theta to x. So you get 1 over 8 times cos 4x. Now 1 over 4, 1 over 8, I can take the LCM. So that will give me 3 over 8. So this is 3 over 8 negative. In fact, 1 over 4, when it comes in, there's a 2 there. So that has to be placed. So 2 divides 4 2 times. So it's going to be 1 over 2 times cos 2x. So these two are clubbed. And this is taken care of. And all that remains is 1 over 8 times cos 4x. And that is exactly what is required. Express the sum of terms with no exponent involved. We do not have any exponents at all. So that is question number 16. It's a very good question. And we will move on to the next one. So this is question number 17. We are expected to show that sine raised to the power of 4x negative cos raised to the power of 4x is equal to negative cos 2x. So you can start off by consider the left hand side, which is sine raised to the power of 4x negative cos raised to the power of 4x. So I can rewrite this as sine squared x negative cos squared x multiplied with sine squared x positive cos squared x. Now why am I able to write this? Because a squared negative b squared can be rewritten as a negative b times a plus b, and that would mean a raised to the power of 4 negative b raised to the power of 4 can be written as a squared negative b squared times a squared plus b squared. Right, simple algebra. So by that I am able to get this. But sine squared x plus cos squared x is equal to 1. So this would become 1, leaving us with sine squared x minus cos squared x. But I need to get cos 2x. So I'm going to utilize this property. Since sine squared x is equal to 1 negative cos squared x, in place of sine squared x, I'm going to substitute 1 negative cos squared x. Already there is a negative cos squared x. That would mean I get 1 negative 2 times cos squared x. 1 negative 2 times cos squared x. Now we know that this is a side note, we know that 1 positive cos 2x divided by 2 is equal to cos squared x. So this in turn means 2 times cos squared x is equal to 1 positive cos 2x, which in turn means 2 times cos squared x, negative 1 is equal to cos 2x, which in turn means I take a negative sign out, 1 negative. If I were to take the negative sign out, this is going to be 1 negative 2 times cos squared x, which is, if I were to rewrite this, if I were to take this negative positive, so if I were to have this alone, I can actually make the following substitution, which is on the right hand side it remains the same. So what I have done, I have just taken the negative sign out and I have rewritten 2 times cos squared x negative 1 in this fashion, negative of 1 negative 2 times cos squared x. Now if I were to push this negative sign to the right, or if I were to multiply both sides by negative 1, then I would get the following. So let me write that following over here. So that would mean I have 1 negative 2 times cos squared x to be equal to negative cos 2x. So I have taken this result, taken a negative sign out and produced a representation like this. Then I multiplied both sides by negative 1, so that I have a representation for 1 negative 2 times cos squared x to be as negative cos 2x. Now this is all have been done just from over here, right? This is the note, this is the side note which I have given you here. Now this is the question. This question has been rewritten in this fashion, and then I got this, and then from here sin squared x was replaced with 1 negative cos squared x. Then I produced the value to be as 1 negative 2 times cos squared x. But what is 1 negative 2 times cos squared x? It's nothing but negative cos 2x. So I'm going to write that down here. So that is equal to negative cos 2x, which is equal to the right hand side, right hand side. So that is exactly what is required, and I have proved that. 1 negative, okay, that looks good, fine. So that is the end of this particular question. So left hand side is equal to right hand side. This means left hand side is equal to right hand side. So that's the last straw. So having completed question number 17, we'll move on to question number 18. Now we got cot x positive cot y. So let me start off the evaluation process by using the word consider. Now cot x is nothing but cos x over sin x, and cot y is nothing but cos y over sin y. Now I want to take the LCM as sin x sin y, so this is going to be cos x sin y plus cos x sin y gets cancelled. Okay, sin, this is y, right? So sin x gets cancelled, giving me cos x sin y gets cancelled, giving me cos y sin x. Okay, now if I were to rewrite this as sin x cos y plus cos x sin y divided by sin x sin y, this is nothing but the popular sine of a plus b formula, which is sin a cos b plus cos a sin b. So utilizing this is equal to sine of x positive y divided by sin x sin y. On the left you have cot x plus cot y. Now that is quite a handsome result. So we will move on to question number 19. Okay, question number 19, 2 times cot x divided by 1 positive cos squared x. So let's start off by writing consider. Now as I mentioned to you in the earlier session, Whenever you see cot and tan, convert them into cos and sine. So this is going to be 2 times cos x over sin x divided by 1 positive cos x over sin x raised to the power of 2. This is equal to 2 times cos x over sin x divided by 1 positive cos squared x over sin squared x, which is equal to 2 times cos x over sin x. I take the LCM as sin squared x, so this is going to be sin squared x positive cos squared x, which is equal to 2 times cos x over sin x. Sin squared x positive cos squared x is 1 over sin squared x. You flip them, this is equal to 2 times cos x over sin x times sin squared x. Sin and sin can be cancelled, giving you 2 times cos x times sin x. I can rewrite this as 2 times sin x cos x, which will give us the all important formula sin 2x. So therefore we have an identity: 2 times cot x over 1 positive cos squared x is equal to sin 2x. So that is question number 19. We'll move on to question number 20. So question number 20 is 1 over cosecant x negative 1 positive 1 over cosecant x positive 1. So what I wish to do, I will start off by using consider. The LCM is cosecant x negative 1 times cosecant x positive 1. That's the LCM. So this would give me cosecant x positive 1, and this is going to give me cosecant x negative 1. Positive 1, negative 1 gets cancelled, giving me 2 times cosecant x divided by a minus b times a plus b will give you a squared negative b squared. So this is going to be cosecant squared x negative 1. Now let me go to the new page. So what I've got, I have got 2 times cosecant x divided by cosecant squared x negative 1. Am I right? Okay, that's exactly what I've got. 2 times cosecant x. Now what I wish to do is, I would like to first replace cosecant squared x as 1 over sin squared x. So this is equal to 2 times cosecant x divided by, I take the LCM as sin squared x, so that will give me 1 negative sin squared x. Now 1 negative sin squared x is equal to cos squared x. So substitute that. So that's equal to 2 times cosecant x divided by cos squared x divided by sin squared x, which is equal to 2 times cosecant x times, you flip this, that would give you sin squared x over cos squared x. But cosecant x is what? 1 over sin x times sin squared x over cos squared x. So a sin and a sin gets cancelled, giving you 2 times sin x divided by cos squared x. I will write cos squared x as cos x times 1 over cos x. Sin x over cos x is tan x. 1 over cos x is secant x. This is equal to 2 times secant x times tan x. Okay, and that is the result. So we'll move on to the next one. Okay, this is the next question. We've been given cos x positive cot x divided by 1 negative sine of negative sin x. So this is a negative sign. So let me start off by using the word consider. Now as I mentioned to you, I'll be changing cot to cos x over sin x. So this is rewritten as cos x plus cos x over sin x divided by, now sine is an odd function, that means sine of negative x is equal to negative sin x. So that is going to give us 1 positive sin x, which is equal to, take the denominator, the LCM, to be a sin x. So this can be rewritten as cos x times sin x positive cos x divided by 1 positive sine x. Take the LCM as cos x, so this would give you cos x of sine x positive 1 divided by, now this is actually resting over 1, so if you were to flip it, you're going to get sine x times 1 positive sine x. Now 1 positive sine x and sine x positive 1 can be cancelled, giving you cos x over sine x, which is equal to cot x. So therefore you have this identity, cos x positive cot x divided by 1 negative sine of negative x is equal to cot x. So that is a sweet result. So let's move on to the next one. So question number 22, we have been given sine x positive cos x raised to the power of 2. So let us start by considering this. Now I will be utilizing a positive b whole squared formula, which is a squared positive b squared positive 2ab. By this formula, this can be rewritten as sine squared x positive cos squared x positive 2 times sine x times cos x, right? Now you can club these two together, sine squared x positive cos squared x and 2 times sine x cos x. Now sine squared x positive cos squared x is equal to 1 followed by 2 times sine x times cos x, but we know that sine 2x is equal to 2 times sine x cos x. So that would mean this can be rewritten as 1 positive sine 2x. So therefore sine x positive cos x raised to the power of 2 is giving us 1 positive sine 2x. That is a nice identity. Now let's move on to the next one. So I hope you're able to see this. Okay, this is a lovely question. We've been given sine squared x negative cos to the power of 4x times cosecant squared x. So let us consider the given. I'm going to rewrite this as sine squared x negative cos to the power of 4x. Cosecant squared x can be rewritten as 1 over sine squared x. So now let me take the LCM as sine squared x. That would give me here sine to the power of 4x negative cos to the power of 4x. Now this can be rewritten as sine squared x negative cos squared x times sine squared x plus cos squared x, right, divided by sine squared x. Now sine squared x plus cos squared x is equal to 1. I can state that since sine squared x plus cos squared x is equal to 1, so that would give me sine squared x minus cos squared x divided by sine squared x. Now I can rewrite this as sine squared x over sine squared x minus cos squared x over sine squared x. Sine squared x can be cancelled, giving me 1 minus. I can rewrite this as cos x over sine x raised to the power of 2, which is equal to cos x over sine x is cot x, that has to be raised to the power of 2, which is equal to 1 negative cot squared x. So that's a nice result. Sine squared x negative cos to the power of 4x times cosecant squared x has produced 1 negative cot squared x. So that's question number 23. We'll move on to 24. So this is question number 24. So we've been given cos x over 1 negative tan x positive sin x over 1 positive cot x. So let us consider this. I'm going to rewrite this as cos x over 1 negative sin x over cos x positive sin x divided by 1 positive cos x over sin x, which can be rewritten as cos x over, I'm taking the LCM as cos x, so this is going to be cos x negative sin x divided by cos x positive sin x over sin x plus cos x divided by sin x. So let me rewrite this. If I were to flip this, this will go to the numerator, the denominator cos x. So it's going to be cos squared x divided by cos x negative sin x plus sin squared x divided by cos x sin x plus cos x. I'm going to write it as cos x plus sin x. So if I were to take the LCM as cos x plus sin x times cos x negative sin x, this would give me cos squared x times cos x plus sin x plus sin squared x, and this would give me cos x negative sin x, right? So that is equal to cos x into cos x, cos squared x into cos x, that can be multiplied. So cos cubed x positive cos squared x times sin x plus sin squared x into cos x negative sin cubed x divided by cos squared x negative sin squared x. This is what we've got. Now, is there any way, any simplification possible according to you? If I were to take cos x and sin x, so let me write this down. This is going to be cos cubed x negative sin cubed x. I am going to take cos x out and sin x out. That would give me cos x, and since I've taken cos x and sin x, this would give me sin x, okay, divided by cos squared x negative sin squared x. Okay, so can we attempt further simplification? Now we can use a cubed negative b cubed formula, which is a minus b times a squared plus ab plus b squared. So if I were to use that, cos cubed x negative sin cubed x is going to be cos x negative sin x times, this is going to be cos squared x plus cos x sin x plus sin squared x. Okay, so if you were to place that there, I would get, so this is for your information, so this is going to be cos x negative sin x times cos squared x sin squared x added up, give me 1, positive cos x sin x plus cos x sin x times cos x plus sin x divided by cos squared x negative sin squared x. Now cos x negative sin x times 1, and then you can actually distribute this. So this is going to be cos x negative sin x plus cos x sin x times cos x negative sin x plus cos x sin x times cos x plus sin x divided by cos squared x negative sin squared x is cos 2x. Now this is equal to cos x negative sin x. Now I want to take cos x sin x out, cos x sin x out, so that is going to give me cos x negative sin x plus cos x plus sin x divided by cos 2x. Sin x gets cancelled, cos x added up gives me cos 2x. So I want to use this part, so this is equal to cos x negative sin x plus cos x sin x times cos 2x. So I'm going to write it like this, cos 2x times cos x sin x. Okay, cos 2x times cos x sin x divided by cos 2x. So this is the final result that we have got, cos x negative sin x positive cos 2x times cos x sin x divided by cos 2x. Now this entire question is is actually a little bit tedious because we have to do a lot of simplification. But if you were to change this plus to a minus, this particular question would be a simple question. So if you were to do that, if I were to change the plus to minus, I can show you the output here. That would be a simpler value, simpler result. So this is going to be cos x negative sin x, and this will also be cos x negative sin x. You see, this plus is changed to minus, so we would have cos x negative sin x also here. So that would mean the result is much more simple. So let me show you that. Cos squared x divided by, so instead of plus, if there is a minus, then this would be cos squared x over cos x negative sin x positive, and this is cos x over sin x. So sin x, this is going to be sin x minus cos x, right? Sin x minus cos x, because this cot x is cos x over sin x, so sin x minus cos x, so in the numerator is going to be sin squared x, right? So if I were to rewrite this, this can be rewritten as negative sin squared x over cos x negative sin x, and this is going to be cos squared x over cos x negative sin x. So I can take the LCM as cos x negative sin x, and that would give me cos squared x negative sin squared x, and I can split it. As cos x minus sin x divided by and cos x plus sin x. There is a cos x negative sin x in the denominator. They get cancelled, giving me a value of cos x plus sin x. So that is the bonus question. Okay, so I hope you understood what exactly I am trying to insist here. So let me move on to the next question. Now this is question number 25. I have to utilize this space here. So what I wish to do is, I would like to rewrite this as 1 positive cos x divided by secant squared x is 1 over cos squared x, right? In this case is going to be 1 over cos squared of x over 2. If I were to flip it, this is going to be 1 positive cos x times cos squared of x over 2. Now we know that cos squared theta is equal to 1 positive cos 2 theta divided by 2. Now let theta be equal to x over 2. So that would mean cos squared x over 2 is equal to 1 positive cos 2 times x over 2 divided by 2. 2 gets cancelled, giving me 1 positive cos x divided by 2, which is cos squared x over 2. So in place of cos squared x over 2, I substitute this. So this is equal to, this is all side note, 1 positive cos x. In place of cos squared x over 2, I would substitute this value, 1 positive cos x divided by 2, and that would mean 1 positive cos x times 1 positive cos x will give me 1 positive cos x the whole squared divided by 2. So that is the final solution to this particular question, and that is a good place for us to stop. Thank you everybody. Enjoy your